And finally, we have our written question, which is all about speed time graphs for a car going for a period of 50 seconds. So, first question, nice settler, is just to talk about the maximum speeds reached by the car. Now, obviously, this is a speed time graph. No need to worry too much about making sure, about calculating gradients here. That comes later. All we have to do is identify the maximum value shown. And well, we can just draw a little line there, and we can notice very carefully that our maximum speed there is going to be 4 meters per second. So we're expecting you just to read the graph in this question. Some IGCSE questions are quite nice, just settlers, just to make sure that you're, feel comfortable and can then move on to the next bit. You're then asked to calculate the total distance traveled by the car. Now, I notice when some students do this, they get a bit confused because they think that all we're doing is a simple distance equals speed times time calculation, but no. What you're being expected to show is some kind of understanding that you know that the distance is the area under this graph. Now, to be honest, CIE is a bit loose on how you can show you know this, but I think the best thing you can do is simply write down that statement. The distance is the area under the graph, and you will get a mark for that because you're showing knowledge, you're showing understanding of how we use the graphs to get more information. Really, the marks come from the ability to correctly do some calculations of area. So what we're expecting to see is something like this. Now, there's a lot going on here. We've got 3 parts. Well, that's because we've got a triangle here, a rectangle in the middle, and then another triangle here. So we're using half base times height for both of those triangles and just base times height for the rectangle in the middle. So really when markers are looking for this, they're looking for evidence that you've used the area, and then they're looking for that correct answer at the end, which is 20 plus 20 plus 50, which is equal to 90 meters. So quite a lot of work here to get those 2 marks, but you really do need to make sure you're expressing yourself clearly to your examiner. Now finally, with graphs, you should be aware that we can also get the acceleration, and the acceleration is just the gradient of the graph, and we're looking at the gradient during the first 10 seconds. That's nice and simple. We're going to use a equal to v minus u over t. V is our final velocity, u is our initial, and t is just our time. And the easiest way of doing this is simply to take the top value there, 4, take away 0, dividing by 10 to give you 0.4 meters per second. Now, part of the reason I like using this question is because it's a show question, and therefore you know the answer initially. So what you really need to do is show that working. You're not allowed to simply write down the numbers. You must show where that number comes from, and the best way of doing that is to do a full bit of working as if it's a full calculation problem. Let's move on to the next part. We're then told the mass of the car, and we're asked to calculate the force needed to produce this acceleration. You're asked to state the formula and then show your working. So this is an older style of 0654 question, okay, where they tell you what to write down. The formula we're going to write down, well, we know mass, we know acceleration. Quickly scan of the brain for an equation which links mass and acceleration, and hopefully we've got it, which is F equal to ma. We know the mass and we know the acceleration. Remember, you've actually been given this all in the question, so even if you couldn't do the previous one, you can do this one, ma, and you're going to get 380 newtons there. Now, if you notice, I've got 3 lines of text for 2-mark answer. I would encourage any student to write down the full working in this way, regardless of whether the question asks you to, just so you can make sure you're hitting all of the marks. Last one, and this is a little add-on that we've created in the style of a GCSE question. We want to know about the conditions under which the object is considered to be in equilibrium. Now, this is one that I notice students really struggle with because they don't know exactly what we mean by conditions. We might talk about an object being stationary, and that would be an object in equilibrium. But we're really asking, why is it stationary? What is leading it to be considered stationary and therefore in equilibrium? Well, if we're stationary, we are not accelerating, we're not spinning, we're not rotating, we're not moving. And the 2 conditions required for that one would be that the total or resultant force is 0. Another way of saying this could be that the forces acting on the object are balanced. Similarly, we are looking for the idea that the total resultant moment is 0. In other words, that the moments are balanced. So really, you need to make sure you're hitting both of these points to get both those marks. You get 1 mark for each of those. We're then going to use our answer to number 1 there to try and answer, to explain whether the car is in equilibrium. Really, you just need to think and apply those two conditions. The car is accelerating, therefore the forces are unbalanced, and therefore the car is not in equilibrium because that top condition here has been violated. So when we're marking this question, we're looking for 1, no, the motorbike is not in equilibrium. Oh, sorry, I've written motorbike, I meant car, sorry. And 2, because the resultant force is not 0. Now, some people write because the car is accelerating. That's given in the question. We need you to show a little bit more as to why that acceleration means a non-zero force. So really, we're looking for a statement to say that the resultant force is not 0.